Okay, so for this question here, we're given two circles and we're told the centre and we're told that it cuts the x-axis at 5, 0. So that's where it crosses. The x-axis is here, 5, 0. And we're told the centre here is 0, 0. So then we can already kind of see that, you should be able to notice that, well, the radius, distance from there to there, or has to be equal to 5. Now the general equation for a circle is x minus h squared plus y minus k squared is equal to r squared, where h and k is the centre. And we can see that h and k are 0 and 0, so we get x squared plus y squared is equal to 5 squared. That's just that there. So that's the first part of that problem done. So I'll just put in the 5 squared, or radius squared is there. So we've got this point here, minus 3, 4, and we're asked to show that that's on the circle. Well, then we just substitute. To show a point is on a circle, we substitute it into the equation. So x is equal to minus 3, y is equal to 4, and what do we get? Well, minus 3 squared plus 4 squared is equal to 9 plus 16, which is equal to 25, which is equal to 5 squared. So we'll see that because x plus y squared is equal to 5 squared, and we put in that, we get 5 squared. Therefore, P is on C1, circle 1. Okay, so two circles touch at P, this one here. So P is on the line joining the two centres. Find the equation of C2. So we've got these here, and we see that this here, they join, and that's the centre point over here. Now, in order to find the equation of a circle, we need two things. We need the centre and we need the radius. Well, we know the radius is 5 because it's the same for the two of them. So to get the centre here, what we have to think about is to go from 0, 0 to here. It's a transformation, we can think of it like that. We know that we subtract 3 from the x, it goes from 0, 0 to minus 3, 4. So you've subtracted 3 from the x and added 4 to the y. So to do that same transformation again, it'll bring us to the centre point, because it's on the same line and the radius is the same. So we'd minus 3 from the x plus 4 from the y, and we get the centre point has to be minus 6, 8. That looks very messy, but I'll just fill it in here. We know that the centre for C2, we have minus 6 and 8 is the centre point, and we know the radius is equal to 5. So x minus h squared plus y minus k squared is equal to r squared, and all we have to do is just substitute in here. X minus h is the x coordinate, so it'll be plus 6 squared plus y minus 8 squared is equal to 5 squared. And we can leave it like that. That's the equation. You can square it out if you want, but that's the equation done. I'm going to leave it like that and move on. So we want to find the equation of the common tangent at point P. Right, well, point P, we know, and we look back at the diagram here, this is point P, and what we want to do now is to work out the tangent to P. So I'm going to rub out the rest of the stuff there on that diagram, and what we've got is the tangent here. Now, one way to think about this tangent is that, let's do that again, it's a little bit more like it should be, is that the tangent of the circle is always at right angles to a line drawn to the radius, to the centre. So this here is at right angles to this one, it's perpendicular to this. So if I find the slope between P and 0, the origin, the m of P0, I'll be able to find the line perpendicular to it because you just have to flip it and change the sign. So the slope of the line from P to 0 is always y2 minus y1 over x2 minus x1. You could go rise over run as well, but I think this way is just a little bit better. And we've got our 2 points. We've got x1, y1, x2, y2, and x1, y1 will go as 0 and 0, and the other point is point P, which is minus 3 and 4. So the slope of P to 0 would be equal to y2 minus y1, which is 4 minus 0 over minus 3 minus 0, which is equal to minus 4 over 3. So therefore, the slope of the tangent, flip it and change the sign, it's going to come positive 3 over 4. And to get the equation of a line, all you need is a slope and a point. So I can go down to the box there and fill that in then. So I know that the slope is equal to 3 over 4, and I know that the point P is minus 3, 4, and as ever with these, always write in your equation y minus y1 equals m brackets x minus x1. And we have a point there, we can label it x1, y1, and we have y minus 4 is equal to 3 over 4 times x minus minus 3, which is plus 3. Minus minus gives a plus. Then just to fix this equation up a little bit, maybe multiply both sides by 4, and we get 4y minus 16 is equal to, multiplying the 3 in, 3x plus 9. Bring everything over to one side, and we get 4y minus 3x minus 25 is equal to 0. And that's the equation of the tangent through P. So I think I'll leave it at that there for this question.